Contactor Instrumentation and Control System. Integrated glycol gas contacting monitoring for optimal water removal and system safety. Overview. The glycol contactor is the primary interface where wet natural gas is dehydrated via intimate contact with lean glycol. Its instrumentation system ensures optimal dehydration performance, minimizes glycol losses, and provides early detection of process anomalies. All controls are seamlessly integrated with the overall dehydration unit automation platform, typically via the Distributed Control System, DCS, or a local control panel, and are governed by project-defined safety integrity levels, SEALs. Instrumentation on the contactor is designed to control key process variables such as pressure, temperature, gas and glycol flows, level interface management, and gas glycol contacting efficiency, while enabling fail-safe shutdowns under abnormal conditions. Control objectives and functions. Gas side control parameters. Inlet gas flow control. In systems without upstream compressor regulation, inlet gas flow is indirectly managed via downstream pressure control valve. Flow measurement using a differential pressure transmitter DP cell or ultrasonic meter upstream of the control valve ensures regulated throughput. Contactor pressure monitoring. Pressure transmitter PT at the gas outlet monitors internal contactor pressure. Pressure high trip PZTHH initiates automatic system shutdown to protect the column and downstream processes from overpressure. Gas inlet temperature monitoring, resistance temperature detector, RTD or thermocouple, TC at gas entry point. Monitored to prevent hydrate formation and aid in determining optimal lean glycol feed temperature. Glycol side control parameters. Lean glycol injection temperature. A temperature control loop ensures glycol is at least 3 to 60 Celsius above the inlet gas temperature, avoiding retrograde hydrocarbon condensation. High temperature alarms prevent glycol degradation. Low temperature alarms guard against inadequate dehydration. Lean glycol flow control. Flow transmitters, FT, and control valves, FCV, regulate flow to maintain design unit circulation rate, UCR. For structured packing, minimum flow is enforced to preserve packing wetting. Flow recycle loop maintains pump discharge pressure within permissible limits. Glycol injection pressure monitoring. Pressure transmitters installed upstream of the contactor injection nozzles monitor for line integrity and flow assurance. A check valve at the nozzle prevents backflow and gas ingress into glycol lines. Internal level and separation control, rich glycol and condensate interface management. Chimney tray level monitoring. Liquid level between glycol and hydrocarbon condensate in the chimney tray, if skimming is used, is monitored to prevent carryover to the regenerator. Level interface transmitters, LITE, or guided wave radar devices detect high levels of hydrocarbon intrusion. Bottom section glycol level control, a dedicated level controller, LIC, and associated level control valve, LCV, maintain normal rich glycol level before forwarding to the flash vessel. Level high trip, LSH, protects against column flooding, while low trip, LSL, alerts potential vapor breakthrough or glycol starvation. Foam detection and entrainment prevention. Demister pad monitoring. Differential pressure transmitter, DPT, across the demister mat provides early warning of clogging or foam-induced entrainment. Entrainment can be inferred from excessive differential pressure and elevated glycol loss downstream. Top of contactor temperature and pressure. RTD and PT at the dry gas outlet provide validation of dehydration efficiency and detect temperature excursions that may indicate hydrocarbon condensation or loss of control. Safety and protective functions. Gas blow-by protection. A high-fidelity pressure switch, PSH, located upstream of the level control valve alerts against blow-by conditions due to LCV failure. Interlock logic ties into ESD to isolate the contactor and downstream equipment. Hydraulic surge protection. During emergency shutdowns or turndown, a sudden surge of glycol from trays or packing can overload bottom skimming and level circuits. Surge allowance is built into level alarm logic with sufficient deadband above LAH, level alarm high, and LL, normal level. Corrosion monitoring, optional. Corrosion coupons or inline corrosion probes may be installed on the rich glycol outlet to assess the impact of inlet gas composition and pH drift. Diagnostic and maintenance enhancements. HART protocol and digital diagnostics. All smart transmitters support HART Field Bus for live status feedback, remote diagnostics, and auto-calibration features. Integrated alerts for sensor drift, signal degradation, or calibration errors. Self-test and loop check routines. Periodic auto-verification routines confirm integrity of signal paths, especially during system initialization or maintenance cycles. Accessible instrument locations. All devices are mounted outside hot zones, within reach from walkways or maintenance platforms. Vibration-affected instruments are isolated or supported with vibration-damping mounts. Summary. Instrumentation on the Glycol Contactor combines precise process monitoring with robust safety control. From gas flow regulation and lean glycol feed optimization to rich glycol level control and foam management, each loop is designed to uphold dehydration performance while protecting equipment and ensuring environmental compliance. Smart instrument integration further enhances operational visibility, reduces manual intervention, and supports predictive maintenance frameworks. Glycol gas dryer instrumentation and protective control functions. Precision monitoring and integrated safety in gas dehydration units. Overview. The instrumentation and protective control infrastructure for glycol gas dryers is fundamental to ensuring safe, continuous, and efficient dehydration of natural gas. It facilitates tight regulation of process variables, detection of deviations, emergency protection, and optimization of glycol regeneration and recirculation cycles. All devices and logic systems are specified to conform with process safety integrity levels, SILs, operational reliability expectations, and system-wide integration within control centers or local panels. Instrumentation design adheres to DEP and project-specific requirements for measurement, control, and protective functions and ensures compatibility with hazardous area classifications. Instrumentation scope and functionality. Glycol contactor monitoring and control. Gas flow and pressure control. Inlet gas flows through the contactor at a controlled pressure, typically managed via downstream pressure control valves. Flow is monitored upstream of these valves using calibrated flow elements and transmitters. Contactors situated between compressor stages rely on upstream and downstream compressor regulation for pressure control. Lean glycol flow management. Positive displacement glycol pumps deliver lean glycol to the contactor top. For systems with multiple contactors, flow split is regulated via dedicated flow control valves. In structured packing systems, glycol flow remains fixed to ensure adequate wetting. Flow feedback ensures circulation is matched to required unit circulation rate, UCR. Temperature regulation. Lean glycol temperature is monitored to maintain it above the inlet gas temperature, preventing retrograde condensation and associated foaming. Alarms are triggered if glycol temperature falls below this margin. Flash vessel instrumentation. Level control. Rich glycol level is maintained via a level controller discharging to the regenerator. A proportional type level control valve, LCV, prevents surges or starvation. Pressure control. A split-range controller maintains vessel pressure by diverting gas either to LP fuel gas or admitting from HP gas. Pressure protection includes PSV routed to flare or recovery. Regenerator and reboiler instrumentation. Temperature control. Glycol temperature at reboiler is critical for achieving target lean concentration. Control methodology varies by heating type. Fired heater. Temperature control cascades to a fuel gas flow or pressure controller. Hot oil reboiler temperature cascades to a hot oil flow or heat flow controller. Electric, thermocouple-based PID control. Steam flow control with pressure reduction desuperheat as required. Level monitoring. Although the reboiler uses a weir-type overflow, low-level alarms detect interruptions in feed. Stripper gas flow, if present, controlled via a simple flow loop monitored by rotameter or differential pressure transmitter. Protective functions and alarms. All systems are engineered using HAZOP and SIL review methodologies per DEP 32.10.10-Gen. Key protective layers include trip functions, high-pressure shutdown HPSD on regenerator vapor lines, high-temperature trip in PSV vent line to detect unexpected blow-off or column flooding, pressure switches at glycol flash vessel to prevent gas blow-by damage. Alarms, lean rich glycol temperature alarms, high-low. Reboiler temperature excursion alarms. Level alarms at flash vessel, reboiler, and surge drum. Dew point deviation alarms based on online hygrometers. Diagnostic and analytic support. Online water dew point analyzers, preferably cooled surface or aluminum oxide types, are integrated with DCS. Instruments support HART communication for advanced diagnostics and calibration. Commissioning and functional verification. All instrumentation loops must be verified for continuity and integrity of wiring and signal path, calibration across expected process range, functional response under simulated trip and alarm conditions, proper interlock and permissive operation per control narrative. Environmental and compliance integration. All instrument selections consider hazardous area certifications, Zone 2 or better. Extended temperature and corrosive atmosphere ratings, e.g. H2S exposure. Minimal emissions from flash and still overheads monitored by gas recovery or flare system instrumentation. Summary. The instrumentation and control systems of glycol gas dryers are designed to deliver exacting control over critical process variables while ensuring safety and environmental compliance. With high-fidelity sensors, responsive control elements, and protective interlocks, these systems uphold operational integrity across a range of operating scenarios, from startup and turndown to full load conditions. Glycol Regeneration Unit Instrumentation and Controls, high-integrity measurement and control for consistent lean glycol quality. Overview. The Glycol Regeneration Unit, GRU, serves as the thermal backbone of the dehydration process, restoring rich glycol to high-purity lean glycol for continuous operation. Instrumentation and control systems within the GRU are designed to monitor, regulate, and protect each thermal and separation stage, ensuring consistent water removal efficiency, preventing glycol degradation, and maintaining process safety. The control system interfaces with the Distributed Control System, DCS, or local control panels for autonomous operation and integration into broader plant shutdown and safety systems. The instrumentation infrastructure covers reboiler temperature control, still column vapor handling, rich to lean glycol separation, stripper gas flow if applicable, and flash gas recovery, while supporting diagnostics, redundancy, and safety interlocks. SHASH, reboiler temperature and heat source control. Reboiler temperature monitoring. A high-accuracy temperature transmitter, TT, monitors glycol bath temperature at the reboiler. Optimal temperature is maintained around 204-208 degrees Celsius to avoid thermal degradation of glycol while achieving sufficient dehydration. Heating medium control based on type. Fired heaters, reboiler temperature controller, TC, cascades to a fuel gas flow controller, FIC, or pressure controller. High temperature trips, TS trips, and flame failure interlocks initiate burner shutdown via ESD. Flame scanner and UV detectors ensure burner integrity. Hot oil systems. Temperature control loop regulates hot oil flow through reboiler coils. Flow transmitters FT and control valves FCV manage heating energy input. Steam heating. Steam control valve modulates based on reboiler TT and steam pressure control. Condensate is returned to the utility system with level monitoring in the steam trap. Electric heating. Thermocouple-based PID controller governs electrical input. Over-temperature protection includes dual safety thermocouples and redundant contactors. Still column and vapor recovery instrumentation, overhead vapor temperature and pressure. Thermocouples, TC, and pressure transmitters, PT, track vapor quality and flow stability. High pressure alarm, PAH, indicates potential obstruction or condenser failure. Condenser monitoring. Vapor is routed through an air or water-cooled condenser. Inlet and outlet temperatures are monitored to ensure effective condensation. Differential pressure transmitters detect fouling or partial blockage. Hydrocarbon condensate knockout drum, if applicable. Level instrumentation maintains proper interface between glycol and hydrocarbons. Excess condensate is drained through a level control valve, LCV, and high-level alarms, LAH, trigger ESD if unattended. Flash vessel and rich glycol preconditioning, flash vessel pressure control, a pressure control valve, PCV, vents flash gas to fuel gas recovery or flare. Split range control may be applied depending on downstream handling systems. High pressure switches, PSH, initiate trips on vessel pressurization. Rich glycol level control. Guided wave radar, GWR, or displacer type level transmitters control discharge to the heat exchanger or directly to the reboiler. Low-level alarms prevent pump starvation. High alarms, LHH, prevent flooding. Hydrocarbon skimming, optional. Rich glycol is skimmed for condensate using interface-level controllers like recovered condensate routed to waste oil or recovery system. Stripper and sparge gas control, if applicable. Sparge gas flow control. Flow transmitter, FT, and control valve, FCV, regulate inert or fuel gas injected into the bottom of the stripping column to improve glycol purity. Flow is maintained at low, steady rates to prevent glycol foaming. Column pressure and temperature. Temperature transmitters at top and bottom of the column validate dehydration efficiency. Pressure transmitters ensure safe venting to the condenser or flare system. Gas outlet monitoring. Flow and temperature measurement at the vent ensure emissions compliance and column integrity. Glycol pump protection and transfer monitoring. Pump, discharge pressure, and flow. Pressure transmitters on the lean glycol pump outlet verify integrity and check valve function. Flow measurement confirms proper circulation rates. Pump seal leakage detection. Leakage sensors or drip pans with proximity switches identify seal failures for maintenance intervention. Pump interlocks. Low suction pressure or high discharge pressure automatically isolates the pump. Vibration sensors, if rotary or centrifugal, monitor for mechanical degradation. Safety, shutdown, and interlocks. High temperature trip. Reboiler vapor line includes a high temperature switch, TSH, to detect excessive glycol boiling. Flame failure and combustion safeguards. Burner management system, BMS, with multiple permissives ensures safe startup, flame hold, and shutdown logic. Flame detection using UV-IR sensors with dual validation. Level and pressure trips. All vessels are protected by high and low level switches, LSHH, LSL, tied into the ESD system. Pressure trips, PSHH, prevent rupture or reverse flow to upstream systems. Instrumentation diagnostics and maintenance. Heart smart devices. All critical transmitters support heart or foundation field bus diagnostics, enabling early fault detection and remote calibration. Built-in test capability, BIT. Instruments can run self-check routines and loopback tests during commissioning or troubleshooting. Accessible layout. Instruments are mounted in accessible locations with proper cable routing, tray support, and junction box labeling. The instrumentation system within the glycol regeneration unit, it is engineered to ensure consistent glycol purity, safe thermal operation, and seamless process integration with temperature-regulated reboiler control, precise flash gas management, and reliable stripper gas operations. The GRU maintains the lean glycol specifications required for effective dehydration. Embedded diagnostics, safety interlocks, and redundancy ensure the regeneration process remains stable, safe, and aligned with long-term operational and environmental performance targets.